Hi students, Professor Nugent here. In this video we are going to discuss confidence sets for multiple coefficients estimated using ordinary least squares for a multiple regression model. Let's say that we have equation 1. We are estimating a regression of yi on beta naught plus beta 1 times x1i plus beta 2 times x2i all the way through beta k times xki plus ui for observations I equals 1 through n. Now, what is a joint confidence set? A 95% joint confidence set is a set-valued function of the data that contains the true coefficients in 95% of hypothetical repeated samples. Equivalently, this is the set of coefficient values that cannot be rejected at the 5% significance level. You can find a 95% confidence set as the set of beta 1 and beta 2 that cannot be rejected at the 5% level using an f-test. So, in essence, we're taking a confidence interval and making it two-dimensional. And when you make a confidence interval two-dimensional, you have a confidence set. But we need to use the f-test. We can't just combine the two 95% confidence intervals. Recall that when you went about inference using that one at a time approach, the size of your test was actually larger than you intended. So we need to use the F statistic to construct the 95% confidence set in order to construct a two-dimensional confidence region within which we believe the set of beta 1 and beta 2 will reside 95% of the time. So let's let this F statistic, F beta 1, beta 2, be the heteroscedasticity robust F statistic testing the hypothesis that beta 1 equals the beta 1 null hypothesized value and beta 2 equal to the beta 2 null hypothesized value. And typically we are testing that beta 1 0 is equal to 0, beta 2 0 is equal to 0. Then the 95% confidence set is given by the values for beta 1 and beta 2 such that their F statistic is less than 3. That is, 3 is the 5% critical value of the F2 infinity distribution. Recall that this distribution is equivalent to the chi-squared over q distribution. This is the distribution of the heteroscedasticity robust F statistic. This set has coverage of 95% because the test on which it is based, the test that it inverts, has a size of 5%. So 5% of the time the test incorrectly rejects the null when the null is true. That is a type 1 error. So 95% of the time it does not. Therefore, the confidence set constructed as the non-rejected values contains the true value 95% of the time, or equivalently in 95% of all hypothetical samples. Let's look at the math to try to see how we would construct such a confidence set based on this F statistic with 2 degrees of freedom. So we're looking at all of the values for beta 1 and beta 2 such that the F statistic is less than or equal to 3. Recall that the F statistic is given by 1 over 2 times t1 squared plus t2 squared. These are the t statistics, minus 2 times their correlation, the correlation between t1 and t2 times t1 and t2 over 1 minus the correlation squared. we can rewrite f as 1 over 2 times 1 minus the correlation squared times t1 squared plus t2 squared minus 2 times the correlation times t1 times t2. We can take this f statistic and write it as a function of the estimated coefficient and the null hypothesized coefficient by inserting or substituting in the expression for t1 and t2. And that is what you see here. Here we have substituted in t2. Here we have inserted in t1, right? t1 is equal to beta 1 minus the null hypothesized value for beta 1 all over the standard error of beta 1. t2 is beta 2 hat minus the null hypothesized of beta 2 all over the standard error of beta 2 hat. So we substitute in these values for these expressions for t1 and t2, and we have an expression for the f statistic as a function of the OLS estimate for beta 1 and beta 2 and the null hypothesized values for beta 1 and beta 2, their standard errors, and the correlation between the test statistics. Now this expression is a quadratic form in the null hypothesized values. So the boundary of the set defined by this f statistic is an ellipse because of the quadratic form. So let's look at that. Here we have the 95% confidence set for the coefficients on the student-to-teacher ratio and EXPN from equation 7.6. And the 95% confidence set for the coefficients on these two things is an ellipse. The ellipse contains the pairs of values of beta 1 and beta 2 that cannot be rejected using the f statistic at the 5% level. Note that, importantly, the point beta 1, beta 2 equal to 0 is not contained in the confidence set, and therefore the null hypothesis that beta 1 is equal to 0 and beta 2 is equal to 0 is rejected at the 5% level, significance level. So, outside of the confidence set, we would reject any of these null hypothesized values, right? Within the confidence set, that is where we believe the true population coefficients to reside 95% of the time. And this is it for confidence sets. I am working on how to visualize a confidence set using Stata. We will plot coefficients using Stata in the Stata tutorial.